What's going on, everybody? It is the mustache version of Josh. I shaved my beard off and left my mustache to freak out Nicole. I think that it worked sufficiently. But today we're back for another STL Sunday. Basically what we're going to be doing is I'm going to take a project and draw it live in CAD just to kind of show you guys the process of taking some idea that you have and breaking it down into something that you can draw. Today we're going to be using, and always, Fusion 360. That's an Autodesk product. That's the CAD program that I'm using. And it is a free program that you can download. I've linked to it in the description, so you can go there, find exactly the program that we're using to draw. Now, most of what I'm doing is going to be with the idea that you're going to then take this file and 3D print it. So whatever we draw today, I'll be putting that file out for download. You can grab it yourself to 3D print it, or you can kind of try and follow along slightly as we're drawing to make your own version. What's going on, everybody? Thanks for stopping in. I'll let all of the mustache comments roll in as we get going. I told her I'm keeping it for a week just to bug her. But anyway, like I said, this is going to be for 3D printing most specifically, and then I'm using Cura to 3D print. I don't usually go through the slicing system that I use. That's kind of up in the air. You can use a lot of different things. The printer that I use is a TiVo Nearest here at home and a TiVo Tornado at the office. So those are the two that I use the most. Those are the two that I'm most comfortable with, or at least currently those are the ones that I have used most recently. Today I've come up with a couple of projects. We'll see if we have time to tackle two. In the past we've only done one per video, but I think maybe we're going to do two. Today I wanted to take and try and design something around something else. And that is something that I do often. It's trying to take and fit an item with 3D printing also combined. And today I'm going to try and use a little mini voltmeter. These are something that I use all the time. I've designed a lot of things around miniature voltmeters. So this isn't a huge diversion from something that you may have commonly seen me use. So I'm going to take this, but what I'm going to do is I'm going to try and draw a Racepak style gauge cover for this. If you're not familiar with what a Racepak gauge is, that's like the dash that a lot of race cars will use. So it's this all digital display that goes in, and you can basically configure it to do anything. Super common in the racing world, and something that I think would fit well into your scale truck. We'll make it so that it's pretty universal, but we're going to hide a little voltmeter behind it. So, all of the, it's Mario. Are you a cop? So now we have a porn stash. Oh my God, that's creepy. Yes, this is great. Oh my God, go shave that shit off. Put me in, coach. This is great. Try to speak with an Italian accent. I think you guys are all on my wife's team. I think she put you all up to it. So anyway, let's get into drawing. We've changed things up a little bit. I'm using a new EVGA keyboard with the macro switches on the sides. So now I can change the scenes on their own buttons. That way I hopefully don't hit switches and make you guys stare at what you're not supposed to be looking at. Let's see if that works. It's all good in theory. Own button, now we're on Fusion. You can see in the bottom corner of the screen, you can see the I was Google image searching for some Racepak things. One nice thing with a lot of full-size, custom application dashes like this is you can just search Racepak template, and then all of a sudden you have an exact 2D drawing template that you could use to download. So that's actually what we're going to do. So we're going to save this image. Just save it to the desktop. Racepak. So now we're good there. So I've saved that drawing, and now I can actually, we're just gonna, so you don't have to stare at that. a little bit more screen real estate on Fusion. Okay, so we've got a clean Fusion document here. One thing I'm going to do at this point is I'm going to take our calipers and we're going to just grab a quick outside dimension of this little voltmeter. Now we're going to want some overlap, but I'm still going to grab outside dimensions. So this is 10 millimeters tall by 23 millimeters wide. We're going to start a new sketch from the top. Oops. Sorry, all out of whack here. We're actually upside down, but not important. D for dimension, after grabbing that, I said it was 22.75 millimeters wide and 10 millimeters tall. I'm going to hit L for line again and then X to change it to a construction line. That's just so you can like draw lines that don't really affect what your profile will be. Then I selected the origin and that new construction line so I can hit the center point constraint. That just kind of puts everything in the center where I want it. So that's our basic shape of the outside of the voltmeter. That's just to kind of give us a kind of a place to start. But I'm going to go up now and I'm going to actually hit insert and then canvas. And from here, insert from computer. We're going to hit Racepak. I know some of that stuff doesn't pop up for you guys to see. It's sometimes those. But basically what we did is it allowed us to, we're just going to hit OK for now. It got us brought in there. So you can kind of see that's that shape of that Racepak. And now from here we can actually go into those canvases and then right click on this. Well, sorry, you guys can't see it for some reason. Some reason it doesn't show everything on my screen, but up here in this area, there's a little tree that kind of goes down and it shows canvases, and then you can right click on the thing that says Racepak and hit calibrate. Now I can click over on this and we're going to just go, well, we're going to kind of go rough on this for now. I'm going to go from outside to outside, and we knew it was 22 millimeters of our full voltmeter, so we're just going to make this like 25 millimeters for right now. We can adjust this. For the most part, I just kind of want to use it as as something to look at. We're going to hit, I can just move and copy this around. Free move. We need to, it's actually hit edit canvas, but we're just going to kind of move it roughly centered. 1.5 millimeters. So as you can kind of see with this, the corner of our Racepak is outside, or the corner of our voltmeter is outside of that Racepak. So we've got a couple of things we can still do. I'm just going to spend a little bit more time kind of playing with where I want this thing. And at the same time, we can kind of take and tweak the actual size and proportion dimensions of everything to make it fit. This is kind of like what I'm assuming. We're trying to fit a rectangle inside, and I don't want this little thing that we're going to create to get so big because it's just not going to look properly proportioned for the type of item we're using. So this is where we're going to start. So we've got that done. Let's jump over to comments just for a second again, just to see how many more mustache comments there are. Let's see. It's Vanquish Undercover Brother. Josh has a 5 o'clock shadow by 10 a.m. Yes, it comes back quickly. An idea for you to print. How about a pinched grill for a Toyota Hilux? That's hard because there is no standard pinch. You have to kind of, you can't just do one. I shaved my beard and left a mustache over 2 months ago. Now it's growing back. This will be back quite soon, I feel like. I'm guessing next week I'll have what resembles a beard again. Josh joined the Vermont Highway Patrol. God. All right. We're going back to CAD. So we're going to start a new sketch on that same top plane. So we're going to start with some just basic geometry. Clicking the line tool or hitting L for line, either way. Now at this point, I've got a line created. You can kind of see I'm dragging around. There's a tree on the right here, I can click construction, and I'm just going to do that and then go over and connect to that other side. That way, I'm just going to make sure that those two sides are equal length. You can do it with an equal length control as well, but that's not what we're doing. Now, if you look at the shape of the Racepak, if we actually just grab the arc tool, arc and then 3-point, if you tried to connect all of the points of the arc, you wouldn't be able to match it, because you can tell that there's more than one radius to this arc here. So see, if I did that, I can touch the top and the sides, but not everything matches. So instead, what we're going to do is we're going to hit arc, 3-point arc, and then we're going to grab this thing at a few spots, but I'm going to keep one up close, up more at the top, just because I think you can tell that that's more of an area with a consistent arc. And then we're going to finish it off by, we're just going to draw one side for now, and then drag that down. So I can select those lines. I still had it set on construction by accident, so if I select it and hit X, it makes it an actual line. Now, one thing I want to do is I want to select our first top line segment, our next one, and then I want to hit tangent up at the top, and that'll make those actually a proper curve rather than kind of having a sharp point or a spot where it's not a smooth transition. And then we can actually you can see you can click and drag on that, and we can actually just kind of try and match it. So we'll get it to somewhere where we like. And while that matches it, I want to grab this line and then this vertical line too and hit tangent on that. That way it stays proper. But we have this issue here where that line is not covered. So we're going to carry this up a little bit, so we get some coverage on it. And all of this can be easily modified. Say we want to make it slightly larger, anything like that, to try and make it fit more of the exact proportions of a Racepak. We could easily do that. I did also joke that I'm keeping this until the Proline van body comes out. I don't think she'll allow it. So to get this to cover the top of that corner of this voltmeter, it's getting too tall. So instead, we are going to make this a little bit wider across the bottom. So we're at about 25 now. Let's go to 28 millimeters and see what that looks like. We need to get it centered, so we'll actually start from the center of our first. All right, we're just getting things in order. So now that we made it a little bit wider, you can see we have a little bit more room up here. We don't have to carry that as far up to make it. Well, you can see that didn't like that. Being that we don't have things constrained yet, things are kind of jumping around. So let's throw a line on this top portion, just to make sure that everything stays where it's supposed to. Then I'm going to grab another construction line and just take it to that side so that everything stays a little bit more even. Since we're not going with any like super hard points here, we have this. That's looking better. So I think that looks a lot better than where we were at. You look like a mailman. Oh, that's a new one. Take your hat off. No, my hair is not in the right state. I'm going to grab this left arc here. Well, actually, I'm just going to, rather than mirror it, I'm just going to do it the other way, just so that I've got. I'm going to just make sure that everything is tangent to each other. So, all right. So that kind of gives us the shape of our Racepak. You can kind of see the canvas is still under there. And if we scaled it up a little bit more, it'd still be closer. It is all a bad dream, like TV show Dallas. God. This isn't a long-term look, don't worry. He looks like Cliff from Cheers. You guys are killing me. So we did the outside shape. I do want to put an area on the inside. So I'm going to create one more rectangle. And now that rectangle, I want to overlap the face of our voltmeter. It's going to cover up slightly what we've got going on, but I want it just so that everything looks, you know, more single, like one piece. It's all kind of covers everything up. We're going to make it, we're only going to go with like a 1 millimeter overlap though. So 0.5 millimeter per dimension to do that. So we're just going to create all those dimensions, put them as 0.5. So, what do we got there? Do that. Now, let's do an extrude. So let's go up 2 millimeters. We don't need anything crazy for now. We got that in there. Let's turn off the canvas. I don't think we'll need it for now. So now that we have that part of it, these little voltmeters do have these little little mounting tabs on the side, and that's what we're going to try and make everything sit to. So from the face of the voltmeter to those mounting tabs is 6 millimeters, and then center to center on those is 26 millimeters. So we'll start a sketch on the back side here. Well, actually, let's exit that sketch. One thing we need to make sure is that these are on center, and it does look like it is, but it's always worth checking just to make sure. About, yeah, I think it's on center. Close enough. Looks like an out-of-work highway engineer. Hey, well, no, I still gotta work. So we're going to create the circles of where our mounting tabs need to be. The other thing is that, like we said, the outside of this is, we'll call it 23 millimeters. Center to center, I think we said was 28. We'll double check that. Let's it's 26 millimeters, not 28. Let's see. The concentrated stare at the voltmeter while raising one of your eyebrows is absolutely hilarious. Huh. It's the little things you just, sometimes you don't notice. One thing is that we did draw the voltmeter at the center of that rectangle, so we can base all of these mounting positions off of it just the same. The diameter of the hole is 2.25 millimeters, so we'll call it a 2 millimeter screw. So let's do these as 1.5 millimeters. That gives us some interference for the threads of a 2 millimeter screw to bite into. So we dimensioned those circles at 1.5 with the D key, and then I selected both of them, hit equals at the top just to make everything the same. You look like you should be designing fishing lures. We're going to throw a couple of circles around the outside so we have some material to actually become the bosses of for our screws. Now, let's do another rectangle, a center point rectangle. I hit the construction to make it all for construction. And I'm doing that so that I can dimension the outside. I want to make it 24 millimeters. It's going to be too tight. 23.5. I want to give us just a little bit of wiggle room for interference of the part to sit in there more correctly. Matthew McConaughey on Dallas Buyers Club. Wow. You look 20 years older than you should. What's the dirt squirrel on your upper lip? You need the matching chin or at least soul patch. God. I think it's hilarious. Nicole does not agree. So I'm going to make these bosses. Let's see, where did that go? That line disappeared once I hit. There we go. Right, oops. So I just rotated around so that I could make sure that it's not letting me make these tangent to it. So we're just gonna have to kind of I think we're gonna have to make that kind of just on our own, but using that as a guide. D for dimension. We'll go 2.875. That's a pretty small area where you're gonna have to be careful when threading into these is all. 2.875. We are making fun of Josh's new look, yes. So if you're just tuning in, what we are doing is we're drawing a Racepak style gauge cluster to hold an electronic voltmeter. I'll link to which one I'm drawing this off of. I get these off of Amazon. They're just like a couple of bucks. So you can pick these up pretty easy. Fairly inexpensive. They usually come in like a 5-pack for 10 bucks or something like that. And you can make yourself one and all your friends. So one thing is that you can see our boss's area now is kind of going over the actual area for the voltmeter. So instead of allowing that or trimming that, we'll go back to our second sketch technically. We're just going to increase this thing to 30 millimeters. then that gives us a little bit more to work with. So let's rotate around so that we're just looking at it in a way that we're familiar with. Is that Mario? All right, we're gonna put, let's just give these things a little bit of area to make sure that they hold without a problem. Using rectangles, just clicking on the origin areas. Just a little bit more area for it to print, give it some support while it's trying to print that thin area. What happened to your face? He's like Freddie Mercury, only he can't sing. Where's the Popeye tattoo? What do you mean you can't pay for your pizza? I'm sure we can work something out. This is the best part of this stream. So now we've created those little areas. We need to drag those up, and I think I said that was 6 millimeters off. Yeah. So just to be, we're just gonna go 5.5 just to give it a little bit of area to tighten down onto. Did you trade the JK for a 1987 Trans Am GTA? Your serious face is even more serious now. God. No breaks from you guys. You're making it a lot easier for my wife to make fun of me. Please just say it. It's me, Mario. This is ridiculous. So we've got some mounting points for that now. This area around it will be the area that will just like sit up against a Lexan dash or an interior of whatever sort you're trying to use. It's super simple to try and use that. Now, if you wanted to, you could put in some pretty simple, like almost areas to kind of just snap over or hook over a Lexan body just to try and make it more of a press fit. Yes, say that in Mario's Italian accent. That is never happening. Oh, Josh will be opening a bait and tackle shop now. If Matt grows fun, we'll have Mario and Luigi for Wednesday Night Live. I feel like I have to keep this for Wednesday at least. Sorry, Josh, but the stash has to go. Looks like a caterpillar. This is a strong mustache. I'm just saying. Let's see. Your trash can sleeve looks level, but now you need to level the Christmas tree. Yeah. Oh, you know what? I forgot to turn on my backlight. What? There we go. So this is a very simple part to do something like this with. I mean, it just takes nothing to accomplish. A super simple insert like this to 3D print, throw on whatever you're trying to. So let's just do a 2 millimeter. That's too much. I'll change that to a 1 millimeter. One thing we can do is let's go back to this and I'll show you Chrome. looking at the Racepaks, they do have like this visor area over the top. Oh, this is an aluminum dash area. I guess you can get it different colors, but you can kind of see there's like that. It's got a raised lip around the front to kind of give it just like the visor of a dash like you would normally see. So let's try and put a little bit of that detail in it. It'll make that face look smaller. It'll make everything look a little bit more appropriate too. So I want Nicole to kick you straight in the dingleberries. Start doing a handlebar mustache. I'm not even watching the Fusion screen. All I see is your face. God. Going to create this visor. So, oh, I've got hidden edges turned on. You're seeing the shapes on the backside because the hidden edges view is kind of turned on, but it's not a big deal. So we're gonna hit P for profile, which is one of those new fun tools I've learned lately. That creates that. We're gonna use an offset tool and select that. Let's go, we're gonna flip it. And we're gonna do, I don't wanna do 1 millimeter on a wall like this. I wanna do like 1.6 because most 3D printer nozzles are 0.4 millimeters. So that gives you 4 actual paths around it. Try and do it in multiples of 0.4 millimeters. So that gives us that. And then we're just going to, well, yeah, we're going to give it an ending point at like the mid span of this side. That, extrude, and we're just going to I don't know why it won't let me. Hold on a second. There we go. So we're going to extrude that up. Let's just go, why not, 3.5. So while that's not the look we want, it gets us a start. Then we're going to click the side view, and we're just going to trim this whole thing. We're going to go like that. Grab an arc. This is all just kind of a style thing here, which of course I'm the one you should be listening to for style now, obviously. I don't know why it's not letting me select there. Either way, all right, we'll figure this out. So select those profiles, drag through. You should just, we're going to modify that to go through everything. That. Something like that. I thought Aaron, I don't know who Aaron Rodgers, who's Aaron Rodgers? Don't hit the like button, smash the like. Oh, there you go. I thought you were going to make some sort of stash the like button. Or what? So I'm going to change the display style to just regular shaded. And at the same time, I don't think I like the arc we did. I'm just going to go to a straight line cut. I think that looks better than the arc style. Let's throw a radius in this area. 10 millimeters. There we go. Make it flow through there a little bit better. Aaron Rodgers is the Green Bay quarterback. See, I'm not a sports ball fan. You need to gain some weight and you look like Ron Swanson, and you can look like Ron Swanson. I just lost all the weight. So we've got let's throw a couple of little radius on the inside of this. Make it look just a little bit more like a cleaned up panel. He looks like he's one of the cheesy vacation dads who wear a Hawaiian shirt and a fanny pack. Fanny pack it is. It's Ray Finkel. Laces out. Pretty sure I can hear Nicole laughing in there. So what kind of... We only have a little bit over 1 millimeter down here on the base, which is just not enough. So we're going to kind of go back and just make a couple of quick edits to make sure all this works, or works a little better. We're going to make sure that that's, if we're at 0.4, we'll go, what is that, 2.2? And then we'll make this make a couple of little changes just to make sure. Oh my God, what is up with the Super Mario mustache? You can always tell when someone jumps in who hasn't been in the chat for a little bit. Chamfer the opening. We could do that. Nice little. Let's do like a 1 mil. 1 mil chamfer on the opening. That looks good. So now we've got some thickness down here at the bottom to make sure it 3D prints easy. The actual voltmeter will sit right in there. Now these things are so thin that if you are, if you were trying to 3D print this and put them in there, those things may actually become kind of they might break off depending on your material or how good your print is. So it's one of those things is like, it might be easier, especially since this goes in there or sits on the back side of it. Maybe we don't even do these. Maybe we just, let's see, can we just drag that whole feature to the outside. So if we wanted to make this just an easy option for, let's just do an offset of 1.5 to the inside. Does that clip? Not quite. Let's go 1.25. Just enough. And then we're just going to create a couple of other lines that we'll throw some dimension on. We're going to keep these a 0.5 millimeter off that wall. Where's the HD going? That's a good question because this is a really tiny piece. We'll put that on the second part. This part's going fast enough that we don't have to worry about it. But now if we just take those areas and say we pull those up 3 millimeter, what this will do is this will allow you to take the voltmeter and like center it in there. That way you don't have to try and get everything perfect. It'll just center it in there. You can use some shoe glue to hold it in place, and then everything should fit into the body still without much problem. We throw a little radius on the edge of these. Ooh, gets rid of too much. Throw a radius on the edge of those just so you don't end up with a real sharp point. But it just gives you something to 3D print to, gives you something to center it so you don't end up with like a crooked voltmeter, and should make it easier to get this to fit in the body and won't be as difficult. What I would do, since this is the face that you'll see in the end, I would print this with this as the bottom and then use support material to hold everything else. Shouldn't need too much support, honestly, but that way you end up with a nice clean 3D printed face. So that is a super simple way to take and input one of these little voltmeters. Go full screen so you know the mustache is even better. Super simple. I'll link to these little voltmeters, the ones that I use, because there's different sizes. So I like these because they're a little bit more compact than the larger ones that I used to use. But these come in different colors: red, blue, green, yellow, all that. Pretty handy to have. And it's actually handy to have in your vehicle. You can tell, you just wire the red and yellow to one side, you run that to your positive and the black to your negative. And then you can tell where your battery voltage is at on your vehicle. Again, it's nice to have. You can tell where your car's at all the time when you're on the trail. Super simple. The next thing I wanted to draw is those little, you ever do one of the, you're seeing people use the thumb steering type wheel. It's one of those options where I always drive one-handed and I can actually reach my steering wheel, but a lot of radios you can't, or sometimes it's just not as comfortable as you'd want. So, oh, my on-air light isn't on. You're right. We're too far in at this point. How long would this take to print? That probably very quickly. Let me open up Cura, and it will give me an estimate. Let me see. I should be able to add it. We're going to go to let me see, hold on 1 second. Just going to see if I can add So this is what the 3D printer software itself looks like. So if I take and I'm going to export the body from Fusion 360. Hold on a second. I don't know why it won't. That's okay. Let's see, this is a Racepak. I'm just saving it. All right. So if we open the file in Cura, this is kind of how it comes in there. This is the way that I would print it, just like it's shown here. Simple with that to the back. In my drop down here, we'd want to go down and make sure that support is clicked everywhere. The support 50-degree overhang, that's fine. You could print this at 0.2 millimeters, which is kind of, it's pretty standard for what I print at. You could go to like fine and make it at 0.1 millimeters. There's some presettings in here. I don't usually use too much of the preset, but so if you go to fine, 0.1 millimeter, it'll give you a little bit. Again, we'll make sure that support is done. Then we'll hit slice at the bottom. And 23 minutes down right there at the bottom, you can see. If you hit preview, it'll kind of show you what the actual look should be. I use brims around the outside to see how everything, run that first. And then these portions underneath there where it filled in is the support material. Pretty simple. So there's your answer. 23 minutes is what it says this should take. Yes, and this was too small. We didn't end up putting the what do you call it? That thing. HD logo on it. So, like I was saying though, I did have one other project that I wanted to do, and that was to do a thumb steering type wheel. And that is going to be another simple one. But that one we're going to use with a couple of pieces of hardware to adjust to multiple sizes for steering wheels. So, should make it a fun, simple project. Again, we're going to start a sketch. We're going to start with a circle. And I'm going to just take a quick measurement off the Futaba wheel that I have here. Now, steering wheel sizes are going to vary so greatly. Mine's 49 millimeters, basically to the outside of the foam. But if you really try and squeeze down on that foam, I'm under 44 millimeters, and I still have some foam area left there. So let's make this thing 50 millimeters to start, and I'll show you how I plan to. So that's to the inside. The outside, let's do this as like, I think, so 4 millimeters. Let's do it 5 millimeters thick. And then we're going to go ahead and put the brake into it now. So we're going to do an area at the bottom that is going to be left open. So I put a line between them to make sure that it was level. That way it gives us and let's do this as like a 8 millimeter opening. I think that's enough adjustment, squish, to give us the area that we need. So I'm just going to grab that outside ring, and we're going to, my steering wheel itself is about 20 millimeters wide, but let's make this thing 13 millimeters, which is about a half an inch. So that's going to that. Then we're going to start by, we're going to create another sketch on one of those areas that we cut. So I made a dimension 3 millimeters from that bottom edge just because I know that this was 5 millimeters thick, so it leaves me enough room there. Now, since we added that 3, let's go to, I think 13 is going to be plenty, or if not too much, but we're going to put a hole in the center of that, or the center of the area that's left open. Drew a line in the center area, then hit X to make it construction. The center of that, we're going to make this 3.2 millimeters because that's going to allow us a pass through for a 3 millimeter screw. Oh, we need to select both of those, join. Now we're only going to be able to drag this so far out before it's going to start breaking. You're not going to have enough overlap. And it's not till there, which is almost 10 mil. We're going to go to 6. And that feature, I'm going to mirror to both sides. So at the top, we're going to drop down and hit mirror. And we're going to objects, we're going to select that last feature we did. The mirror plane is going to be the right. Hit OK. Why didn't it do that? Well, that's odd. I don't know why it didn't cooperate there, but rather than really trying to figure it out, we're just going to knock this out. Super simple. We're not going to run through everything. 3 millimeter overlap, 13 millimeter total length. Right, 3.2. All right, we're almost. Okay. I tried to make that -6 as well. Why didn't it do that? There we go. Have you been watching Chips? How about the back hook on the 4PV for a lanyard? Yeah. That's trying not to make it too actual item specific, at least at this point. I know what you mean. But that's, I would if it wasn't so specific. So anyway, we did this, and that's just going to be to give us that clamping style. But I do want to do one more thing to this, and that is that I want to go here on this side. Then we're going to go in, and you can use the, where it is, the Polygon Tool. Select that, and we're just going to, the default number is 6, which is very handy for us since I want to use this for a standard hex nut. Standard hex nut for a 3 millimeter screw is 5.5 millimeters, so we're going to go 5.75, just give it some area for it to drop down into. Depending on how accurate your 3D printer is, you could go tighter, you could go looser. So, and then we're going to use that to just cut in 2 millimeters. Now when you put a M3 lock nut in there, it'll hold it in place. You don't have to grab a pliers or anything like that. Super simple. Put a little radius on each side here. Call it 3 mil. Let's go 5. Right at it there. Now on this side, I'll want to use a button head screw or washer. If you wanted to, you could do the same thing we just did. And grab like a screw, use 7 millimeters, and we barely touch it. But let's just, for the sake of this, say that we want to countersink this in. We're going to hit the 2 sides and 2 millimeters. So it'll countersink the head of the screw. It'll countersink the nut. Just makes it a little bit cleaner. So this will grip it. Now this is the simple part. This is what will go around the wheel of the radio. And it will give us the base to then add our steering portion of this. So do that now. We'll just go to here. And I'm just going to say that we're going to put this at the bottom, and then we'll put the thumb steering portion to the side. We could try and actually like integrate these pieces more into each other so it looked more, you know, simplified. But again, this is just something simple. I don't need to get crazy into overthinking this for now. So I'm going to pull some basic geometry. Oops. L for line, X for construction. And then so it kind of depends, you know, you could make this shaped however you want. Let's make sure that the points of this are all equal. So now we can doesn't want to pull down, does it? Oh, that's because of this. That's fine. So we can make this kind of however shaped we want. Now, if I was going to use this, for me, you know, if it came out, you know, maybe you have smaller hands than I do, or your radio shaped a little bit different. Let's just go 25 millimeters. And I'm going to create a point out at the very end. So we're going to dimension from that point to, you know, well, basically we know that we did 50 millimeters total, so to the inside. So let's just go 75 millimeters now. Don't know why it doesn't want to let me type. So 75 millimeters. And we need to take it down -13. Our favorite radius tool gives us just simple. What in the hell is on your face? Somebody kill it. Hello, Brittany K. Just got here and Josh is going for the Burt Reynolds stash. Yes. Why don't you 3D print the screw to go with it? You shouldn't be putting that much. What's it? Why don't you print the screw to go with it? you shouldn't be putting that much force on it. I don't know what you mean. Oh, you're saying there shouldn't be that much force so you could print the screen. Oh. I mean, you technically could, but 3mm hardware is everywhere. It's just, I don't know why. But now to save some 3D printing effort, we're going to go in and P for profile, grab the area that we need. Select those, and then we're going to offset that by, let's do 5mm again. Oh, I see what we did though. We're gonna go back and edit that other sketch. I brought these in at a quadrant point rather than tangent. And that is why that doesn't look correct. And now I could have drawn that differently, but in the interest of just fixing it, we're going to do that. So that looks better. Oh, and then there's, yeah, someone else noticed it at the same time I did. that did not look proper, so. And, well, we need to make, edit that sketch. We need to offset that 5mm. But I just want to cut this through. Just saves you a bunch of space that you don't have to 3D print. Pretty simple. Knurl the end. Okay, that's not too hard. And if we do it around certain areas, it shouldn't. So how do we want to do this? Let's do it with a circle. That way we don't have any hard edges for the printer. 1.5mm radius. Okay. And then we're going to go to circular pattern. We're going to select the object, select the center point, and now it's making a bunch of them, but we don't actually have to use those. We're only going to select the ones that we want. We're going to go 22 of those little things. Then we're going to do a cut. And so we've selected all that. We're going to do a cut all the way through. There. Now I've got, it is properly gripped, knurled, whatever. But one thing that we did is I cut that all the way through over here. What happened? Let's not cut it all the way through. I went -25. Let's go, it's 13mm wide. Let's go to -11. Oops. That leaves us a little area. And the reason is, we'll go there, top, text, this is where we select HD, impact font, that's not tall enough. 8 millimeters tall. Can we fit 10 min? That, and then we just need to rotate this. Text angle 180 degrees. Just won't let me. I'm sure there's a reason it won't let me just grab and drag this, but whatever. One millimeter tall. Now, since I said I was going to try and save 3D printing, I'm going to go back and we're going to still cut some of this out. Actually, we don't need to do that. We just offset. It'll be fine. No. I was right the first time. Right, we're just gonna 2 millimeters off. Radius. Hey, what do we got there? Seems reasonable. Let's throw a little bit of, clean these up a little bit. $3 mil. Clean that up. These inside ones, since as these things pinch together, they could kind of start to dig in. I'm actually still going to throw a little bit of a radius on there. Now, the other thing is that being that how we're going to try and use this, and it's kind of just a press fit on foam, we could take and do our same knurling style, but the opposite almost. It's going to go 2 mil, and we're going to pattern that around as well. And we're going to do just like 7 of them, sure. And now the reason for this will be, it'll give the, you know, this clamping style something to actually bite into the foam. So gives it something to bite with. Now, this is the outside face. Oh, we put the knurling in. I don't think it'll let me. Can I put a, what will a 1 mil? It actually will. Okay, let's see what even a 1/2 of a millimeter chamfer will look like. It just kind of cleans it up a little bit. Gives us a better looking edge. Yeah. There we go. What happened to your face? I went full on Ron Swanson. So, what are we at? We're a little over an hour to do both parts. That's kind of the purpose of these. Not too long, gets everything done. Again, I'm going to save out both of these files and I'll upload them both to Thingiverse. You guys can download them, 3D print them as you wish, try them out, or try and draw your own off of kind of along the lines of what we just did. Doesn't have to, it's just taking an idea and making it into something. If you guys have other things you would like to see for these projects, drop them in the comments of the video. You know, always looking for simple things that are more universal rather than very specific items for a specific truck. Did you draw your stash in CAD before cutting it? When is the van coming out? You'd think I would know with a mustache like this. So, oh, one more thing. Let's put a chamfer on this opening. That looks better. Yeah, I like that. Flying cars tomorrow? Absolutely. I am excited to watch Flying Cars. I'm buying it on iTunes, and that's where I plan to watch it. We'll go through a few questions here before killing this thing off, but that's really the end of what I had planned for the CAD portion of this. Nothing more advanced than that. Just trying to take something simple and go. I'm going to scroll up a little bit. I know if I missed a ton of comments, mainly about mustaches during this, but I'm going to scroll up just a little bit and see what I can catch. Man, I need to get a 3D printer. I need to start researching. The TiVo ones are on the list. Are there any other brands that are good for beginners that are also somewhat compact? You know, Creality seems to really pump out a lot of them, like the Ender 3, 5, 6. There's a bunch of those. A lot of them anymore seem like they're pretty decent. They're all very, very similar construction, made from very similar components that are all sourced from the same place. So, you know, there's pluses and minuses to everything. I suggest the TiVos because those are the ones that I own myself and they've worked well for me. So, you know, I'm just going with what I know has been reliable. You could make an HD logo pass through so it's hollow looking. Oh, that is true. The only problem with making them hollow looking is if you try and do that hollow, this area here is just like the, you know, little dangling bits. Those are usually pretty weak. And then the D would be completely hollow and you wouldn't get that definition. So for that reason, I'll probably leave it like this. I don't think I screwed up once today on the split screen. The new keyboard, I think solved it. I was a little bit worried because this E5 over here is right next to my control button and I use control all the time. So if I would have hit that, you would have got my desktop and then I could have messed up. But it looks like I stopped from screwing that up. So even I'm happy about that. Oh shit, the mustache is real. Yes, I posted on Instagram about it, and then but it wasn't real until. Is the filament expensive? I've never done 3D printing before. No, filament is so cheap. Like the cost for you to print this part that we did for the steering wheel would probably be like literal pennies, 4 cents, 5 cents worth of material. It's just the cost of the filament itself is almost nothing. I use it for basically throwaway tools at this point, like the 3D printing stamps that I made. Let me grab those. So, my project last night was a new bed area for this thing. So, do I still have that set up? I think I do. Oh, of course, that camera is frozen now. I've been having problems with my cameras freezing, and I don't know why. But anyway, you see the bed area on this thing. How it's got like that ribbed look. I did it to try and make it look like a full size, truck bed, how it's got like the ribs in it. So to do that, I printed these big pieces here. Now each of these pieces, because of the size and the thickness of them, these things are like over 7 hours to print each, so they're big pieces. But then I take these and I put this aluminum between them and smash them together with a hammer, basically, and create these pressed metal panels. We got a whole video on that process, but the cost of the material for 3D printing is nothing. So I used these once, and now these are basically just throwaway. I don't need them. I'll keep them with the project bin for now, but that's it. This was the styrene one that was in the truck, and that's what I replaced with the actual metal panels instead. But gives you an idea. It's like the cost is so negligible. Is there a way for making a stamp to do dimple dies? Yeah, there is, and I've tried experimenting with it a little bit, and I think I would need to fine tune my design style. The way that I was looking at doing was drilling a hole first and then trying to dimple die it in a way, but I needed to fine tune the best design to make the style look right. It's we got more into what happened to your face. EVGA fanboy confirmed. Yes, I've got my new. I've got a 2060 KO in this machine now. This is a new EVGA mouse. Except the mouse, I think I do need to go back to a wireless mouse in here. The mouse is nice, but this desk is big, so having other cords is a little much. Having the big keyboard for this type of thing works out pretty well. But like most of the time streaming, if I'm not trying to have a keyboard be like a big focus, having a wired mouse and keyboard's a little awkward. So I gotta work out some things there, but we'll see. And then I have a 2070 Super in my editing machine, which is the bed turned out awesome. I really am happy with how it turned out. I'm not always, always like, oh, maybe I could do. And there's a couple of things I could change on this just because of, I measured everything, on a live stream, just like measured it and threw it together. And there was a couple of dimensions I could have adjusted a little bit. And if I felt like reprinting 15 or 16 hours worth of stamps, I would do that, but I'm not in a big hurry for it. Is that stamp in PLA or PETG? It is PLA, regular PLA, 20% infill, 0.2 millimeter layer heights. Simple. They work great. Glad I got to see how that turned out. Yeah, I'm super happy with how this thing has come together. You need to put those files on Thingiverse. I would love to be able to make press metal from your design. I mean, like I said, I can throw these up on Thingiverse. It's so specific to this cage that I don't know who it would necessarily be good to, but if you want the files, you can have them. let's see, Logitech G Pros are nice. I actually run a Logitech G602, like an old style. Like that's what I run on my editing machine. I actually love that mouse. Wired mice, great if you need the latency. Check out the Logitech stuff if you want to wire. I run Logitech on my other stuff. Would you guys pick a G-Speed V3 or Brazen all-time low frame? That's flat rail stuff. Get a C channel. EVGA is the official reference board partner of NVIDIA. Yeah. Is there any tire rub on the body at full flex? It's barely there. Well, and the rears aren't spinning because I have the dig disengaged right now, but it would just barely touch. If I didn't want them to, I could move the shock holes one more back and it would be fine. How's the cat? He's doing better, but not, I don't know. We'll see. Not out of the woods yet, but hopefully he makes it through. What size is the aluminum you're using for your panels? It's 0.025 inch thick annealed aluminum. The annealed is the important part. It's a softer, it's perfect for this type of thing. How long does it take to learn how to use AutoCAD for the purpose of making body panels suitable to create RC truck bodies such as an M43 Power Wagon? I mean, body design in a CAD like that is not the best place. You know, that's like organic body design and things like that are usually done in other programs. It's not, and I mean, even at that, it's going to take you a very long time, you know, hundreds, if not maybe thousands of hours of practice before you're competent enough to make a body that looks good. You know, you can make something that looks passable maybe in a, you know, couple hundred hours of practice, but it's going to take you a long time to get to a place that's actually good. How many parts can you press before the panels break with PLA? I have no idea. I've never done so many that they've actually broke. Most of the stuff that I'm doing is for a one-off project. I'm not looking to do a production thing. I'm looking to make a panel for a purpose, and as long as it makes the one or maybe two, if I screw something up, then I'm good. With that one, I made two because I did this in halves. So I like overlaid it, partially through it, stamped it, put it over it, partially stamped. Worked great. Are you bringing the Woods Runner to Badlands? We'll see. I haven't decided if I'm going yet or not. Just pre-ordered flying cars and iTunes. I hope it's not a total train wreck. Oh man. I'm thinking I should get it now. I need to get it, make sure that I have it, and I wonder what time it actually releases. If it's midnight my time or, what AutoCAD programs do you suggest for beginners? This whole video I've been using Autodesk's Fusion 360. It's free, and it's a great place to start. Tons of tutorials, things like that, where you can actually go. Any idea of limit of depth in 3D stamps? I don't know yet. I keep wondering. I've started now doing hard edges, like just perfectly vertical edges, and it's been super clean still. I don't know how far I can go though with this material before it's too much for either the material or the print. If it's too much for the print, then I could just stiffen it up with more layers or more, you know, wall thickness and go from there. I haven't pushed it that far yet. Thanks, BT, for the kind words on the cat. You should dressing and print a flat rail. You should probably means design and print a flat rail chassis using PETG just because you can. We could basically do a flat rail chassis in one of these. Just there's nothing to designing flat rail chassis. There just isn't. You can make some tweaks and designs over time, but they're so simple. Even the ones that actually have some taper to them, there's just nothing to it. Josh, thanks for helping us learn. You and your wife rock. Thanks. My wife watches with me and pretends to be interested. I think she was hoping yours walks in, spices things up. Hope the cat is doing better. Thanks, guys. Appreciate it. Have you ever thought about getting a 3D or resin 3D printer? So I have a Form 2 at the office. And for certain things, I've used it, and the resin printers are actually super cool. A little messy on cleanup, and you got to do a lot of hand finishing to get the support areas off, but they're very cool for what they are. But also that printer's like, it's like $2,500 or $4,500. It was an expensive printer. You can get cheap ones, the little ones that are cheaper, but that Form 3, or yeah, whatever, Form 2, Form 3 is very nice. What would be the most suitable gauge of sheet metal for body panels? 040 or less? Planning on building a Woods Runner chassis with custom-made CJ3A body. 040 would be way thick. I think you would be best off at like that 025 or less, depending on aluminum or steel. You want to keep, or 040 is thick. You'll want to be significantly thinner. Google says Flying Cars is coming out the 19th. Oh, I was incorrect. I thought it was the 18th. Thank you, Jeremy Burris. Some nice body panel templates would be nice. That's a tough one. Body panels are not easy. That's a whole nother level of design. And just like I said, it's a different style of design usually than what we're using here. I wonder if Flying Cars will ever be on Netflix. Oh, man, I think it'll be on YouTube before Netflix. I think designing a fully 3D printed tiny truck would be a great set of streams, but I think you would end up making oh man, maybe if it was smaller, but man, I just don't see it holding up. What about some geometric door panels and seats? Oh, that's an interesting one. And yeah, that's actually, if, you know, the one thing with the material that I'm using is you have to go somewhere and order it or things like that. I wish it was, if I could find something that was easier to get, I would feel better, you know, like here you should do this to get it so that, you know, I like to, whatever we're printing, to be able to be used easily. But doing some door panel inserts or something like that for something more it would be an interesting one. I like that. What I should try it for is the Origin, my VS410s, just because. I like your idea. What is Flying Cars? Oh, let me tell. You should go back to my Wednesday night stream with Matt, the Wednesday night takeover, and watch that. What about designing a 3D printed body to vacuum form a setup? That's, again, 3D printing, doing all of that for a body would be tough. And to do it, you would actually need to do a lot of body work, because vacuum forming would show all the little imperfections. It would just be it'd be a lot of work. But this stream, we're an hour and a half in. I think we're going to call it. This one's just supposed to be a quickie. So thanks for stopping in, guys. It's great. Appreciate it. Appreciate all the interaction and, you know, the introduction to the mustache. So anyway, that's all I got. Thanks for watching, guys. We'll see you, well, Tuesday for the Scale News update. So see you then. See you guys. Bye.